Hi students, as a part of spectroscopy, today I am going to explain with you about the very important spectroscopy, which is nothing but IR spectroscopy, that is infrared spectroscopy or OR. It is also called as rotational vibrational spectroscopy. So why it is also called as rotational vibrational spectroscopy, I have clearly explained in one of my video. So if you want to know why this particular infrared spectroscopy is also called as rotational vibrational spectroscopy, please do watch that particular video. The link of that particular video is provided in the description box. Now before going to dive into the infrared spectroscopy, I will discuss I will throw some light on the importance or application of this particular infrared spectroscopy. So this particular infrared spectroscopy is especially used to determine the functional group of the molecules. Functional groups of the molecules. Right? Now, the name is self-explanatory that this particular infrared spectroscopy utilizes infrared radiations. Infrared radiations. Now, I will discuss about the principle involved in infrared spectroscopy. Infrared spectroscopy. Infrared spectroscopy. The principle. So, whenever the IR radiation, because already I have discussed that this particular spectroscopy utilizes the infrared radiations for the changes in the molecule, for irradiating the molecule. So accordingly, infrared radiation is irradiated on the molecule. So whenever the infrared radiation is irradiated on the molecule, then what happens is vibrational transitions takes place. Vibrational transitions takes place. That is, vibrational energy changes takes place. Vibrational energy changes takes place. Vibrational energy changes takes place. Energy changes takes place. To be precise enough, the molecule gets excited from lower vibrational energy level to higher vibrational energy level. So this is the brief principle involved in the IR spectroscopy. That is, whenever the IR radiation is irradiated on the molecule, then vibrational transitions takes place in the molecule. In fact, vibrational energy changes takes place in the molecule. To be more precise enough, whenever infrared radiation is irradiated on the molecule, then molecule gets excited from lower vibrational energy level to higher vibrational energy level. So this is about the principle involved in infrared spectroscopy. Now let us see the range of infrared region. Range of infrared region. And the range of infrared region is usually represented in centimeter inverse. Now here, centimeter inverse corresponds to the wave number. Centimeter inverse corresponds to the wave number. Now the infrared radiation ranges from 25 centimeter inverse to 12,500 centimeter inverse. Infrared radiation ranges from 25 centimeter inverse to 12,500 centimeter inverse. Here centimeter inverse is wave number. Right. So this is. So infrared radiation ranges from 25 centimeter inverse to 12,500 centimeter inverse. Now, based upon the range, which is ranging in between 25 centimeter inverse to 12,500 centimeter, which is lying in between this particular range of 25 centimeter inverse to 12,500 centimeter inverse. This particular infrared radiation range can be categorized into three categories. One category is 25 to 400 centimeter inverse. So if the infrared radiation range is in between 25 to 400 centimeter inverse, then it is called as far infrared radiation. On the other hand, if the range of infrared radiation ranges from 400 to 4000 centimeter inverse, then it is mid-IR region, mid-infrared radiation region. If it ranges from 4000 to 12,500 centimeter inverse, then it is called as near infrared radiation. Now, based upon the range of the infrared radiation, which is lying in between 25 centimeter inverse to 12,500 centimeter inverse, this particular infrared radiation can be further categorized into three ranges. One is near far infrared radiation, which lies between 25 to 400 centimeter inverse. If it lies between 400 to 4000 centimeter inverse, then it is mid-IR radiation. If it lies between 4000 to 12,500 centimeter inverse, then it is nothing but the near infrared radiation. Now, do remember, students, that IR spectroscopy will not utilize the entire infrared radiation range, that is ranging from 25 centimeters to 12,500 centimeter inverse. So before that, so in order to remember the far infrared radiation range and the near infrared radiation range, I will give a tip for you. Far infrared radiation means the lowest value, it is 25 to 400 centimeter. Whereas near infrared radiation is nothing but the highest value, that is 4,000 to 12,500 centimeters. So let's come back to the actual topic. This particular IR spectroscopy, in order to determine the functional group present in the molecule, this particular infrared spectroscopy will not depend or rely upon the whole range of infrared radiation, which is lying in between 25 centimeter inverse to 12,500 centimeters. So among the three regions, that is far infrared radiation, mid infrared radiation and near infrared radiation regions, mid infrared radiation region is the one which is used to determine the functional group present in the organic molecule based upon this particular infrared spectroscopy. So among the three categories or three range of categories, the one which is lying in between 400 to 4000 centimeter inverse, that is the mid-IR region, will give the information about the functional group present in the molecule, because most of the functional group, almost all the functional group lies in between this 400 centimeters to 4000 centimeter inverse. So to be more accurate, to be more precise enough, what I did is this particular mid-IR region, which is helpful for determining the functional group present in the molecule, I have categorized into two regions again. So already said that mid-IR region is the one which is especially used in the IR spectroscopy. So which ranges from 400 to 4000 centimeter inverse. So to be more precise, that is, in order to get the information, in order to know what is that region which is especially used as the functional group region to determine the functional group present in the infrared spectroscopy, I have categorized this particular range of mid-IR from which is ranging from 400 to 4000 centimeter inverse into two categories, into two categorized ranges. So one range is from 400 centimeter inverse to 1500 centimeter inverse. Another range is from 1500 centimeter inverse to 4000 centimeter inverse. Now, do remember, students, that whatever the region, infrared region ranging from 400 centimeter inverse to 1500 centimeter inverse is called as a fingerprint region. Fingerprint region. Whereas the infrared radiation which is ranging from 1500 centimeter inverse to 4000 centimeter inverse is nothing but a functional group region. It's nothing but functional group region. That is, we are going to find the functional groups. We are going to observe the functional group within the range of 1500 centimeter inverse to 4000 centimeter inverse only. So this region is very, very important. Now, when this region is very, very important, because this is the region where we can observe the peak related to the functional groups. Why we are regarding this particular region which is ranging from 400 centimeter inverse to 1500 centimeter inverse, which is the fingerprint region? Why we are recording that? So fingerprint region. Now let us discuss something about the fingerprint region. So fingerprint region, the name is self-explanatory. Fingerprint. Now, as the two human beings will not have the same pattern of the fingerprints, even the twins will not have the same pattern of the fingerprints. Same pattern of the fingerprints. In the similar fashion, no two molecules or compounds will have same pattern of peaks in this particular fingerprint region. No two molecules or compounds will have same pattern of peaks in a fingerprint region. So fingerprint region, in this fingerprint region, we are going to get the information about the molecules, that is closely related molecules, closely structure related molecules, So in order to simplify the things, I will consider the example of methanol and ethanol. Methanol and ethanol. Now, in both this methanol and ethanol, what is the functional group, students? The functional group is a hydroxyl group. Functional group is hydroxyl group, and you will find somewhere around here, that is around 3400 to 3700, you will find only one functional group in this, because only the single functional group present in this one. So by seeing this functional group, we cannot differentiate these two molecules. Because both have the same functional group, hydroxy only. So you will get only one peak in the functional group region, which is ranging from 1500 centimeters to 4000 centimeters. Now, by observing one peak which is corresponding to the OH group, we cannot decide which molecule it is. Right. Now, these two molecules are closely related with respect to structure. closely related with respect to structure. So why they are closely related? Because it is one carbon, that is CH3. Here there are two carbons. Only that is the difference. So even the slight difference is there in the structure of the molecules. So definitely you are going to get a different pattern of peaks in the fingerprint region. So different pattern of the peaks you are going to get in the fingerprint region, even though they are the geometrical isomers. So what is the difference between geometrical isomers, students? One is cis and another one is trans. Right. Molecular formula is there, molecular structure will be same, everything will be same. Only the thing is one is cis and another one is trans. So even though they are the geometrical isomers cis and trans, they will give the different type of peak pattern in the fingerprint region. So fingerprint region is unique for the molecules. Unique for the molecules. But with the help of the fingerprint region, we cannot reveal much information. Much information. It is used to differentiate the molecules which are very closely related in their structure. No doubt in that. But it will not give the clear-cut information. Why? Because if you see the fingerprint region, you will observe the complex number of peaks. You can observe the number of peaks in the fingerprint region, right? So in the fingerprint region, you can observe the number of peaks arised usually by the bending vibrations. And what are the bending vibrations, stretching vibrations, all I'm going to explain in the subsequent classes. So as this fingerprint region is complex due to the presence of n number of peaks, usually it is not straight. But do remember that what is the significance of fingerprint region, students? It gives the information about the molecules which are closely related in their structure. I hope you got it. So as the two human beings are not having the same fingerprint pattern, no two compounds or molecules will have the same peak pattern in the fingerprint region. But whatever the peaks which are obtained or observed during the recording of the IR spectra of any of the molecule, n number of peaks are observed. So due to n number of peaks which are being observed, we can say that this particular fingerprint region will give the complex spectra. So as it is complex, and the complex spectra is obtained related to the fingerprint region because of bending vibrations. And what are the bending vibrations? I am going to explain in the subsequent classes. Right. Now, let us see the examples of some of the important functional groups ranges in this particular region, that is functional group region. For example, if we take alkane, so if you take the alkane, then you will observe the peak in between 2850 to 2975. If it is hydroxy group, then you will observe the peak around 3400 to 3700. If it is alkene, that is C double bond C, then you will observe the peak corresponds to 2100 to 2250 in functional group region. If it is the alkene, you can get this also C double bond C H, which is observed at 3300. Nitrile 2200 to 2250. Aromatic compounds 1650 to 2000, that is If the molecule is aromatic compound, then we will get one peak around 1650 to 2000 in this particular functional group region, which is ranging from 1500 centimeter inverse to 4000 centimeter inverse. So amines, you're going to get the peak in the range of 3300 to 3500. Carbonyls, so in the carbonyls, so many carbonyls are there. We have the ketones, aldehydes, acids, esters, accordingly. So if it is aldehyde, then you will get the peak. You can observe the peak around 1720 to 1740 in the functional group region. If it is aldehyde, you will find or observe 1715. If it is if it is a ketone, if it is the ester, then you will get the information, you will get or you will observe or appear this 1735 to 1750 in the functional group region. And if it is the acid, if it is the acid, then you are going to get the peak in between the range of 1700 to 1725 in the IR spectrum. So this is about the introduction or basics which are required to understand the IR spectroscopy. So in the upcoming classes, I am going to explain the IR spectroscopy in detail. I will make the IR spectroscopy very easy for you. So in this particular video, I have explained about the principle involved in IR spectroscopy, and what is the IR range, what is the fingerprint region, and what is the functional group range of different functional groups which are being recorded in the IR spectrum during the recording of any of the molecule in the IR spectroscopy. I hope you understood this video. So thanks for watching.